Hello and welcome to Statecraft IAS Academy. I am Atif, your geography educator. Today we are going to discuss something very interesting that can be linked to disaster management more than geography. For the past few weeks, a week or two, we have witnessed some of the major disasters that have struck multiple locations across our nation. Unfortunately, it has led to a lot of damage, lot of destruction, loss of lives, loss of property, damage to infrastructure. Out of these, you might have heard about the Wayanad landslide. It was a very dangerous landslide that led to a lot of damage. Of course, landslides are always destructive, but since this region is inhabited by people, infrastructure development going on, tunnels being constructed in the region, this has led to more damage. So first, we will discuss about the landslide, then see what happened in Wayanad, and what should be the measures that can be taken to prevent such incidents, or at least reduce their intensity. Second is the cloudburst. Cloudburst events have increased manifold in the past few years owing to global climate change. Like, this is a news article that I took from a newspaper where it was mentioned more than 22 cloudbursts struck Jammu and Kashmir in 42 days. A similar kind of news was also about Uttarakhand, where in just a couple of days we witnessed more than 12 cloudbursts. Owing to climate change, this is something that we need to study. This becomes very important for your exam because these events have increased tremendously. Now, when we look at these events, we will study them together because if you look at this diagram, you can see landslide is many a times accompanied due to cloudburst, and we have one more disaster, that is land subsidence. These three we will study together because they are somewhat related to each other. So we need to study them together. This will help us to understand them better, differentiate between the two, because what we have witnessed many a times is that we are not able to differentiate between landslide and land subsidence. So it is very important for us to understand the difference between the two. There is a significant difference, of course. That's why we are studying them separately. Otherwise, we would have studied them together. Now, we will start with landslide first and then go to cloudburst and eventually land subsidence. Okay? So, let's start with landslides first. Now, when we talk of landslides, what is the first thing that comes to your mind? Landslide, something slides under the influence of gravity. Many a times, it can be sudden, it can be developed over a very long period of time. So when we talk of landslide, it involves the movement of rock, debris, or earth down a slope under the influence of gravity. Take a look at this diagram. This image is taken from a landslides site from a national highway where we witnessed a very strong landslide. We can see the entire mass of this rock came down on the national highway and blocked the entire highway, causing damage to infrastructure. Apart from that, you can also see how it also prevents the transportation, loss of property, damage to infrastructure, and many other things. This is one type of landslide where the rainfall can be intense. You can see certain earthquakes causing landslides because landslide is an outcome of multiple processes. It's not something that a single factor is responsible for this. Whenever we talk of landslide, if we witness an earthquake that leads to destabilization of ground or the earth, that can lead to landslide if the slope is unstable. Similarly, sometimes we can see it takes place over a very long period of time. The settlement takes place over a very long period of time. It doesn't happen overnight. The settlement of the ground takes place, and one day when the force of resistance is not able to hold the force of gravity, it leads to landslides. So this is about landslides. There are many reasons that lead to landslides. First and foremost, if we talk of natural phenomena, there are many natural features that cause landslides. Number one, you will have slope degradation, weak plains, soil composition, erosion, temperature fluctuation, seismic and volcanic activities. If I tell you briefly, I know all of you are aware of all these things, what they mean, but I'll give you a brief idea of what each and everything means. Slope degradation is something when a slope erodes over the period of time. See, erosion is something that will always be there. The degradation process always continue. They continue throughout geological time scale. So once the erosion takes place, the materials become loose and more susceptible to erosion. Number one. Number two, weak plains. These are some joints, some faults that are present in the rocks that are susceptible to landslides, to erosion, and other things. Similarly, we have other factors like temperature, seismic, and volcanic activities. As I already told you, we might have an earthquake that can lead to erosion. Then, of course, humans are the biggest culprits that cause such changes, like we have deforestation that leads to landslides, agricultural practices, mining, and other infrastructure development. Today, when we discuss of Wayanad, we will reach there after a few minutes. You will see how it's not because of the entirely because of the natural processes, but humans are responsible for such disasters as well. If you're from Kerala, you might be able to realize how the things work, but if you're not, you will get to know about it. Now, see, this is a flow chart that describes about the flow, how one factor leads to other, and how everything eventually leads to landslide. For example, weak geology of the rocks. That means the presence of faults, the joints, as I already told you. The rocks consist of faults and the joints. If there are more joints, more faults present in a rock, that means the rock is weak. It is more prone to landslide. Number one. Number two, high slope angle. This is again very important and very common. If you use your common sense, you can easily understand. If the slope is more, we will have more erosion, more landslide. Simple example, if this is a land, look at my hand. If this is a piece of land and it's flat, I place this pen on my hand, nothing is going to happen. As soon as the angle starts to increase, it will start to come down. Same is the case with high slope angle. Are you getting my point? If you have any confusion, you can let me know. You don't need to worry about anything. Okay. Now, after this, we go to number three, that is vegetation loss, deforestation, agricultural practices, anything. Because the important thing about forest is that they hold the soil together. Once we cut the trees, the soil becomes susceptible to erosion and it eventually leads to landslides. Whenever these forces, these three factors are there, and then we have some triggering events. It can happen on its own, but sometimes what happens is that we have certain triggering events as well. What are the triggering events? For example, intense precipitation, as in case of Wayanad. We will come to that. Intense precipitation, like cloudburst or any other factor, can lead to landslide. Seismic activities, as I already told you, the rock is already vulnerable. Already there are presence of joints. We have high slope. But if there is an earthquake, it will enhance and it will lead to landslide. Anthropogenic activities, as I already told you, deforestation and other things. All these events will eventually lead to landslides. Now, when we come to landslides, landslides are of many types. We are not going to discuss all of them, but one type of landslide becomes very important as far as our exam is concerned, because the Wayanad landslide might be asked in your exam, and we will discuss the type of landslide that took place in Wayanad. So when we talk of landslides, we have flow, we have slide, we have spread, we have topple, and we have fall. Listen to me carefully. I'm going to give you a brief idea of every type of landslide, but of course we're not going to go into details, but I will give you some idea. Flow, first of all, means you have seen the river flow, how it flows like a river. That is how sometimes the landslide takes place. It is of multiple types: debris flow, rock flow, mud flow. You should remember one thing before we go ahead. Debris flow or debris flow is the type of landslide that struck the Wayanad. I will tell you how it is. We will discuss it in detail. Okay. Second one is slide. Slide is simple. How do you slide on a slide when kids go to the various parks, amusement parks? They slide. It is of two types. Rotational slide, in which, if you look at this, the rock comes like this, rotating down. Okay. And then we have translation slide that simply slides down. Okay. A rock breaks and starts to slide down. A slope. This is a slope. Okay. The rock starts to slide down. This is a slide. If it comes down like this, rotational manner, then that is a rotational slide. Okay. Number 3, spread. This is literally the slowest form of a landslide, in which the soil, the clay content is more, and the soil comes down and spreads along directions. It comes down slowly and spreads along all the directions. It is a soft type of a landslide. Number 4, topple. What is a topple? I'll give you a very simple example. For example, you go out, you're walking or running. Okay, and then you topple onto something. There is something that to topple on. Okay, because if you have some hindrance or objective present there, you can topple onto that and you can fall head first. For example, if there's any, look at me. Well, this is a human being. I know it's very bad. He's walking in this direction. He finds something and he hits it and he falls down head first, topples. That is what we say topple. That is topple. You can see the diagram here. The upper portion of the rock comes down first and then the subsequent portions also come. This is known as topple. And fall is simply falling under the influence of gravity like this. This is my pen. Look at this. It falls down. This is fall. The rock comes down, the mud comes down, falling without being in touch with the slope. They are not in contact with the slope. They fall down, free fall. That is what a fall is. Now, our concern is debris flow. What is a debris flow? Listen, you can first of all look at, I have one diagram here. Look at this very diagram, okay? Initially what happens is that rock has got some porosity. There are pores present on the rock. Whenever there is rainfall, especially during the monsoon season, the rainfall is very heavy. What happens is these pores get filled with water, but they have a certain capacity. There's a capacity, of course. You cannot keep pouring the water onto something and expect that it will get filled. They will get filled eventually, and then you will see once they reach the saturation level, once the saturation level is achieved, what's going to happen? Then the water will start to mix with the soil. It will make mud because now the soil is lost its carrying capacity. It cannot hold any more water. So what will happen? The intense rainfall, the intense monsoon showers will continue and they will mix with the soil. They will make a mud. And look at this diagram, the mud will start to come down. Okay. This is known as debris flow. It will consist of some rocks as well because it comes down with very high speed. It's not slow. The mud comes down the slope with a very high speed. And once the mud starts to come down, it is known as debris flow or debris slide. And exactly this is how the things took place in Wayanad. Okay. If you look at this diagram, this is a very good flow chart here. Initially, you see the fractures that are present in the rocks. Then we see intense precipitation and these pores start to get filled. Once they get saturated, critical saturation and failure. What is the critical saturation and failure? Basically, it's talking of a point where the pores get fully saturated. Now they cannot hold any more water. This will lead to formation of mud and eventually it will start to come down the slope like this. This is how the things come down and this will eventually lead to debris slide. This is something that happened in Wayanad as well. Now, this is a very interesting fact that I want to tell you here. This was a report that was presented by the Minister of State, Dr. Jitendra Singh, in the Parliament, where he mentioned about the total landslides that took place between 2015 and 2022. This is as per the report of the Parliament, where he pointed out that there were more than 3,782 slides for these 7 or 8 years. Out of 3,782 landslides, 2,239 landslides were witnessed in Kerala alone. Can you imagine? Sorry. In just one state, more than 70% of landslides can be seen. Although we might expect that it can be more in Jammu and Kashmir, Uttarakhand, Himachal, because that's a Himalayan state. Yeah, we have landslides in those regions as well. But we witness more landslides in Kerala. In 2024, if you know, a similar kind of landslide was witnessed in Wayanad again. And it was more devastating as compared to the landslide that we are witnessing today. It killed more people. It caused more damage. And this year, just a year, 2 years, we're seeing the landslide again. So what are the reasons? What are the causes? This is the diagram of the landslide from Wayanad. Now, keep these points. You can make the bullet points. You can use them as such in the exams so that you can get better marks. We witnessed a very heavy rainfall in Kerala this time. Why? Because, let me tell you what happened exactly. A kind of a low pressure system was developed in Bay of Bengal. Low pressure system, a depression. Very low, intense low pressure conditions developed in Bay of Bengal. Intense low pressure conditions means it will attract winds from all the directions. I've told you, whenever we witness a low pressure condition, it will start to attract winds from all the directions. Am I right? Exactly. When it started to attract winds, it attracted winds even from Arabian Sea as well. Intense low pressure conditions. Now, for these winds to go to the low pressure, it needs to pass over the peninsular part of India. Right? But we have Western Ghats here. Once the winds will start to blow like this, they will hit the Western Ghats in Kerala, and that is exactly where we have Wayanad. Because of this intense low pressure, we witnessed a huge amount of moist winds that started to move towards the low pressure condition. Are you getting my point? Is there any confusion? One second. Okay. Now, listen. Now, what happened is when we look at these low pressure conditions and the movement of winds from this area was stuck and it led to very heavy rainfall. It's believed that, as per a report, more than 25 centimeters of rainfall took place in one day. It looks very less. What is 25 centimeters? This much? But it's not. You can only imagine that this is this much, but it's not. It is very huge amount of rainfall. This much of rainfall caused this region, the Wayanad region in the Western Ghats. This is very prone to landslide. Why? Because of the construction, illegal mining that's going on, deforestation. If you take a look at this, you can see the machinery that's working here, a tunnel being constructed. So whenever we are doing any type of construction, it makes the rocks weak. This is something that we need to understand. We cannot play with nature. Nature sets the limits. We should respect them. We cannot go beyond them. When we go beyond them, this is a kind of incident that takes place. We face disasters, earthquakes, landslides become more disastrous because of our intervention. When you take a look at this, this was the region that where we witnessed the landslide unfortunate event. There was very heavy rainfall, more than 25 centimeters in one day. Soil reached its saturation point. It got saturated, eventually leading to landslide. On 7th of July, we witnessed the landslide. The interesting news that I want to share is that it was already predicted. A low pressure system was developing in Bay of Bengal and it was intensifying into a depression. Depression means further low pressure. We will discuss about them and we'll discuss the cyclones. That will be our upcoming class. Okay. And it was predicted already that this kind of a condition is developing. And from July 5th to July 7th, we are going to witness a very heavy rainfall. It was already predicted. This is an article from Business Line before the 7th of July. They already predicted that such kind of a condition is going to develop and it attracted winds, led to Wayanad incident, unfortunately. So we should respect the nature. So you can link everything. Whenever you are writing an answer, I would suggest you to link multiple factors. You are writing about the landslide. You can mention this kind of thing, monsoon rains, depressions, everything. Don't stick to just one dimension. That won't fetch you much marks. Now, this is what I already told you. Now, because this has been in news, so I have got some mitigation strategies here. How you can handle or mitigate the disaster, the landslide. Because whenever you see the questions from disaster management, GS paper 3, what you are asked primarily is about the mitigation strategies, not only the disaster. But you will be asked about the disaster along with the strategies that can help you overcome such disasters. So you need to mention all these. Okay? Now, listen to me. There are certain mitigation strategies. This is how you should write your answer. First, we have mitigation strategies. That means those strategies that are done in advance before the disaster strikes. You should be ready for that. For example, if any area we witness more floods, what is it you can do? You can keep life jackets with you every time so that if there is a flood, you can wear it and escape safely. That's a mitigation strategy. So first you should talk of mitigation strategy. Then the second step is response. When the disaster actually strikes, what should you do at that time? That is the response strategy. These are the two things that you have to carefully understand. When we talk of mitigation strategies, we have structural measures in which you can construct the retention walls. You might, if you live in the hilly regions, you might have seen a kind of a retention wall like this, a concrete wall being constructed that prevents the landslide or at least reduces its intensity, causes less damage. Check dams should be connected and drainage should be properly managed because in Wayanad we witnessed the blockage of certain rivers that eventually led to more disastrous damage. If the river channels are properly managed, it won't lead to such a huge disaster. Then we should do reforestation and other, of course, we know about it. There are some non-structural measures as well. We should prepare the mapping. There should be zonal mapping of the regions that witness severe disasters. Building codes should be enforced. When we read the National Disaster Management Act, there are certain building codes that are there that help us understand. Early warning systems should be present. Community awareness should be there. This is the mitigation strategy part. Now we come to the response part. Once the disaster has struck, what will you do at that time? Rapid damage assessment. You should be first able to analyze how much of a damage has taken place. Only then will you be able to take any step. If you don't know about the damage, how are you going to take any steps? Search and rescue operations, of course, you should have NDRF teams there, SDRF teams there. Emergency and medical aid. Critical infrastructure restoration. What is critical infrastructure? Electricity, water. These should be restored as soon as possible. And long-term measures, of course, proper construction, or there should not be illegal construction. Proper construction should be there. Policy integration. This is how you should write this answer. This is a full-fledged answer for you. These slides contain answer for you. This was about the landslide. Now we come to our next part, that is cloudburst. Look at this diagram. You can see rainfall coming down in this region. It's not spread throughout, but in a specified location. This is very important. I'll tell you why. When we talk of cloudburst, it means very intense rainfall in a localized region. That's why I got this image for you, because it shows the rain in this localized region. Very intense rainfall, not in these regions, but it is located in this very region. Okay. So cloudburst is very intense rainfall in a localized region. Now, what is the meaning of very intense rainfall? It's very vague. What is the meaning of very intense? More than 10 centimeters per hour or 100 millimeters per hour. Whenever we have rainfall of more than 10 centimeters per hour in a localized region, maybe up to 25 square kilometers, that is considered as a cloud burst. It's not that the cloud is bursting actually, but it's the very intense rainfall that's taking place. So we should be able to figure out what exactly cloudburst is. 2 points that you need to mention in a cloudburst. Very intense rainfall more than 100 millimeters per hour or 10 centimeters per hour. Second step, in a very localized region, maybe 25 square kilometers up to 30 square kilometers. This was a question that was asked by UPSC in 2024 mains. What is cloudburst? And something was the second part of the question, but this was simply asked, what is cloudburst? So your first part of question is answered from here. Intense rainfall, more than 100 millimeters in a localized region. Now, what is the factor that leads to this? If you look at this image, you can see the winds. These are the warm winds. When they encounter any slope like this mountain, they are pushed upward. They get pushed upwards. The winds, when pushed upwards, will cool down. We have already discussed this. When they cool down, it leads to formation of huge cumulonimbus clouds. When they reach to a certain height, it leads to formation of cumulonimbus clouds. The question here I want to ask you is that, but why cloudburst? We have witnessed many a times that the winds get pushed up, many a times, but they don't lead to cloudburst. But what is special in this? Listen to me very carefully. I'm going to give you one example. Many a times you will see the cloudburst only in the Himalayan regions, mostly. Let's say these are the Himalayas, these are the Great Plains, then we have peninsular India, and finally we have Arabian Sea here. Okay, this. What we are going to witness here is that whenever we talk of cloudburst, India is already hot during the summers. The temperature is very high. Low pressure conditions have developed. They will start to attract winds from these water bodies. When they will attract these winds, these will reach towards the mountains. When the winds will reach the mountains, they carry a lot of moisture. They will be pushed up. Orographic thrust. They will be pushed up because they strike the mountains. Winds are coming like this. They strike the mountains. They get pushed up. They go up. Once they go up, this will lead to formation of cumulonimbus clouds. Now, there should be rain once cumulonimbus clouds are formed. Clouds are heavy enough. They carry a lot of moisture. But instead of the rainfall, we see continuous coming of winds and continuously being pushed up. Continuously being pushed up. Now, what happens because of this continuous push up is that instead of the rainfall, the clouds tend to get bigger and bigger. They tend to get even more stronger, more moisture, more content of moisture. So, what will it lead to? A time will come. A time will come when this pushing up of wind will slow down or not completely stop. It doesn't stop completely, but this cloud becomes very heavy, and now the rainfall will take place because now these upgoing winds will not be able to hold. Earlier, if the winds would have come, if the rain should have fallen, but these winds were pushing the rain further up. Winds are strong, but a time will come when the cloud will become very heavy. It will become huge. See, this becomes very heavy. You can see the winds going up. They are going up. Intense updrafts are present. But a time will come when this updraft will not be able to sustain the moisture in the clouds. The clouds will become very heavy, and this will eventually lead to rainfall that is known as cloud burst. Now, the question here is that why cloud burst? Because I told you, because of strong updrafts, continuously the air being pushed up, and a time will come when the cloud will become highly unsustainable and it will lead to very intense rainfall in this region. Intense rainfall primarily because we have cumulonimbus clouds, and cumulonimbus clouds are always associated with heavy rainfall. For example, you live in South India in Bangalore or Kerala or any other place, or you live in West Bengal, Odisha. What you witness during the summers is that afternoon rain. When we have strong temperatures, very high temperatures, we often witness rainfall at around 4 o'clock. Pre-monsoon showers, what are known as. Why? Because the moisture that goes up eventually leads to formation of cumulonimbus clouds, which leads to a very strong rainfall or even hailstorms. Hailstorms are a different concept. I will tell you someday how that works. But here, the cumulonimbus clouds lead to very strong rainfall. And what's the criteria? 10 centimeters of rain per hour in a localized region, maybe 25 to 30 kilometers square. These are the two criteria that determine the cloud burst. Normally, we see this cloudburst taking place in the hill regions where we have less population. Then why are we so much concerned about this? There is less population. The concern more than the cloudburst is the flash flood that is associated with this. What is a flash flood? Once this much of rain will come down, where will the water go? The water will come down with very high speed, intense speed, and wash out everything that comes in its path. Everything that will come in the path of this intense rainfall will be washed out. That is a flash flood because it's coming out of the slope with a very high quantity of water. It will lead to flash flood, and the flash floods enter the residential areas, damage the houses, damage the property, damage everything. Look at this diagram. When we look at this cloud burst, when the water starts to come down, initially it's coming out of the slopes of the hills, but once it reaches to this region, you can see the houses, roads, all the infrastructure, critical infrastructure, everything will be damaged. That is why I'm telling you, more than the cloud burst, it is the flash flood that's the concern. If you have seen the news in Pahalgam, you might be aware of the Pahalgam due to the unfortunate event that took place last year. 2 days back, there was a cloudburst. Cloudburst took place in the hills, no damage. But once the flash floods came, they destroyed everything that came in their path. They washed away the bridges, they washed away the roads, they washed away everything that came in its path. So our concern is flash flood as compared to cloudburst. Now, when we talk of its management, unfortunately, until and unless we can manage the climate change, there is not much we can do about the cloudburst because it's very difficult to predict a cloudburst. Cloudburst prediction is difficult. We can predict it on short-term basis, but a long-term prediction is very difficult. What we need to work on is management of the post impacts like the flash floods. Okay, how? We should take care of the river channels. If you look at these managements that cloudburst managements, what are there? As I told you, there are mitigation strategies and preparedness. Then there is second stage where we talk of the response. In the mitigation, we should talk of the hazard mapping, the areas that are more prone to such events like Uttarakhand or Jammu and Kashmir. Land use planning. What's the meaning of land use planning? We should not allow the settlement in such regions where these events are witnessed every now and then. Because if people live there, they might not witness a cloudburst for a year or two, but and a time will come when they will witness it. It will lead to loss of life. Okay, building code enforcement, as I already told you, it's mentioned in the National Disaster Management Act. Reforestation to prevent the flow of water. And then we have certain warning systems. One important thing that I need to tell you here is that we need to manage the rivers. If we do the siltation process properly, a proper river channel is managed, we might be able to reduce the impact of flash floods. As I already told you, our concern is not the what I'm saying. Our concern is not about the cloudburst, but our concern is mostly flash flood because that is where we can work. We cannot control the cloudburst, but we can control the flash floods. We can channelize them. If we make proper channels out of the mountains, if there is a flash flood, it might go through it. If we have proper land use planning, we do not allow the people to live in such regions, we might save some lives, we might save some properties, we might save some infrastructure as well. So this is the thing that we can do about cloudburst. Not much we can do, but we should do as much as possible. That was about the cloudburst. Now we come to our last part of the lecture, that is land subsidence. As I already told you, land subsidence is something that is often misunderstood as landslide. The two are different, they are not the same. Land subsidence means the subsidence of the land. Look at this image. You can see this is a piece of land where the land has gone underneath. It's subsided. It's subsided. This is land subsidence. Landslide have been different. For example, these mountains, the land is coming down the slope. That is a landslide. But when we talk of land subsidence, it is different. It is more or less subsidence when the land subsides. Now, this has also been in news. In the Bilar area of Maharashtra, there was a land subsidence where land subsided more than 7 feet. Can you imagine? This is a land, and all of a sudden you witness a 7 feet subsidence like this. 7 feet, more than my height, more than anyone's height. Normally, we don't see 7 feet people. This was witnessed in Bhilar region of Maharashtra on 11th of July. So this is something that is in news, although this is not that big a concern. Yeah, of course, sometimes when it causes too much of damage, then it is in news, as in case of Joshimath. If you are aware of this, Joshimath land subsidence was a huge disaster that killed people, that damaged the properties. Now, let's talk of land subsidence. As I told you, land subsidence means when the land subsides. It can be sudden, it can be slow. As I told you about the landslide as well. What are the reasons that cause this land subsidence? First and foremost, it is the primary groundwater cause. When we take a look at, just a second, if we take a look, suppose this is a ground and we have underneath the bedrock, this is the topsoil, this is the bedrock, correct? Now, what happens normally under normal conditions is we have water present between the pores. Okay, we have presence of water in between the pores of the rocks. So this maintains a kind of a pressure. A pressure is maintained in the soil. So when we construct houses or anything, a pressure is maintained underneath because of these rocks. Correct? Due to urbanization, due to rapid urbanization and exploitation of groundwater, suppose some person comes and puts a hand pump here. This is a hand pump. Huh? I know this doesn't look like a hand pump. And he starts to pump out this water. What's going to happen? This water will get out and the pores will become empty. Pores will start to become empty like this. Now we have pores that are empty. The pressure that was maintained by water is absent now. So what will happen? This land will go under because the pressure that was maintained by water is no more there due to over exploitation of groundwater. So that is my first point. Primary groundwater cause in which we extract too much of groundwater. See, this is the example that I just showed you. There is presence of water and we have a land. Sometimes when we extract too much of water, that will lead to land subsidence. Number one. Number two, in effects of infrastructure. Too much of construction in Joshimath area, a hill region. Too many houses constructed. The carrying capacity of land, you cannot build anything on every kind of land. You have to do the proper assessment of construction. Urban planning has to be there. Land use patterns should be followed. So too much of construction leads to too much of pressure on the land, which eventually leads to land subsidence. It's very obvious. You take anything, you put your hand on it, you might not be able to press it. But if you increase the pressure, you will be able to press it. It's a very simple thing. We don't need to go into too much of details because this is something very simple. Okay, this is number two. Now, number three, very important, is the role of soil compaction. This is something that is very important, and this was an event that took place in Joshimath. Of course, when we talk of Joshimath, there was over exploitation of water, but there was one more thing that you need to know about, and that is soil compaction. Normally, if you read about the soils, about the horizon of soils, we have layers of soils: O, A, E, B, C, and R. If you don't know about these layers, about the soils, about the layers, kindly let me know in the comments. I will get a lecture on that as well. But right now, I'm expecting that you know about the layers of soil. Topmost layer is called the O layer, not present everywhere, especially in the tropics, which contains the organic content, humus. Then there is second layer, that's topsoil, which contains minerals. Then there is E layer, that's elevation layer, from where we have leaching of the minerals that rainfall causes leaching. Then we have B, that is subsoil. After leaching, the minerals are deposited in this region, in the B layer. Okay. Then we have C, where there is presence of parent rock. And finally, we have bedrock. So this is the mature soil type, Whenever you are asked about how you know whether a soil is a mature soil or a transported soil, sometimes the soil is transported because of erosion, because of weathering, other events. If you witness these layers, that means the soil has developed in that place. It is not transported from some other source, because there are proper zones of the soil. You have the bedrock underneath, then you have parent rock, subsoil, elevation, topsoil, and organic. The subsoil is sometimes called as elevation with A. You might get confused. Now, when we talk of places like Joshimath, where we witnessed very severe subsidence in 2022, 21, 22, yeah. It was a huge disaster. That's why I'm mentioning Joshimath repeatedly. When we talk of Joshimath, it is a hilly region. Okay. So there are landslides. In hilly regions, we have witnessed there are landslides. In Himalayas, there are landslides. Now, because of these landslides, this zonation is absent. The zonation that we are witnessing here is not there. Because imagine the topsoil is coming down, so you might have finer particles. Then the solid blocks will start to come. Big rocks. Then some more big rocks. So more or less the ground will be somewhat like this. Instead of a ground where we will have parent rock at the bottom, then followed by other layers. Are you getting my point? This would have been ideal, but in such a region where we witness severe landslides and other things, what happens is that the finer soil initially weathered is deposited underneath. Okay, and then once we get heavier rocks on top, what do you expect in such a region? A home is constructed, a house is constructed, or any other building is constructed, anything. Plus, the water content that was present here has already been excavated. Let me draw this properly. See, in a region where we are witnessing solid boulders on the top, they should have ideally been at the bottom. Then finer particles at the bottom. And because of the presence of urbanization or construction, we witness very huge loss of groundwater. There are too many hand pumps. Hand pumps denote the exploitation of groundwater. Don't take hand pumps in the ideal sense. Whenever I'm talking of hand pump, it denotes the extraction of groundwater. Huge extraction of groundwater is there. The ground is not properly built. The base is not. You're building a home. The base is not properly built. Ideally, there should have been heavy materials at the bottom, then finer materials, and eventually the soil at the top. Then the home should have been constructed. But you're witnessing these finer particles at the bottom and then heavier particles on top with no groundwater or very less groundwater. This will put pressure on this. These will put a very heavy pressure. So what will it lead to? These finer sediments will get compressed because of this much of pressure. So what will it lead to? It will lead to somewhat like this. The houses will start to go like this. They will not be able to hold on to their ground. Why? Because as I already told you, the ground has to be proper. There is no groundwater. There is rapid urbanization, over exploitation of groundwater, and soil compaction is not properly done. This led to the Joshimath incident, and this leads to land subsidence. Landslide and land subsidence are two different things. Please do not mix them. If a question is on land subsidence, you should mention these points. Coming back to our diagram, as I already told you, we have primary groundwater causes. We have effects on infrastructure, how the infrastructure, what it leads to. Then we have role of soil compaction. If the poor compaction is there, the groundwater, the bedrock and the soil and other levels are not properly developed, it leads to land subsidence. Are there any measures that we can do? Of course. First and foremost, we should manage groundwater. There should be limit that should be put on the extraction of groundwater. First of all, you should monitor the groundwater, especially in such fragile environments. You should measure these. Number one. Number two, there should be time to time, once you measure the groundwater levels, Time to time replenishment of groundwater should be done in order to maintain the pressure conditions. Okay. Number three, we should have compaction control. What is a compaction control? We should make sure once we build the house, once we construct the house, there should be proper compaction, engineering, so they make the soils compact. If you look at this image, if it's visible, he's using this compaction drill to make the soil compact in order to make sure once we construct houses on these regions, they don't get pressed too much. And fourth, and the very important thing that you need to know is that there should be proper land use planning. We should not allow construction randomly. We should allow construction up to a limit and not beyond that, because there are always limits. As I already told you, nature sets the limits. It's our role, it's our responsibility that we respect these limits. If we don't, then we will have to pay for it. Are you getting my point? So these are some of the strategies that we need to in order to maintain the land subsidence issues. So these were the three disasters that I had to mention today, because these three, of course, land subsidence, you will not hear that much, but when it is in news, you should know. As I told you in the case of Joshimath, also it was in case of Bilar as well in Maharashtra on July 11th. This is taken from July 11th article. You can read about it from Times of India as well if you want to read about it. But I think I have given you all the important information. There was a 7-foot subsidence of land. Okay, there was a 7 feet subsidence of land. Number one. Number two, this was in Maharashtra, Bilar. And what is the difference between land subsidence? Then coming back to our important topic, that is landslide. And let me go back here. Wayanad landslide. What was the kind of a landslide? What are the bullet points that you can take from it? First and foremost, you should know about it is a kind of a debris slide where we have mud plus rock fragments mixed with water coming down the slope. What was the primary cause? Heavy rainfall, more than 25 centimeters in one day. What was the cause if asked? Well, they will not ask you in this much of detail. Low pressure conditions developed over Bay of Bengal led to heavy rainfall. This region is also an area of construction where a tunnel is being constructed, which also furthered the cause of the landslide and eventually the landslide. Then I told you about the types of landslide. You should go through that slide just in order to have some idea if asked. Mitigation strategies, I have already told you. Response strategies, I have already told you. Use this map whenever you are writing an answer. Use this map. Don't draw the map, but use these stats. These will make your answer look better. 3,782 landslides as per the Parliament report presented by Dr. Jitendra Singh, the Minister of State. 2,239 were alone from Kerala. So Kerala is an area prone to earthquakes, landslides. Okay. Then the second, cloudburst. This is also in news. Asked by UPSC in 2024. What is a cloudburst? What are the causes of cloudburst? I told you the causes. Intense heating, attracting more winds, not allowing the rainfall due to cumulonimbus clouds because of the strong updrafts. Until a time reaches when the updrafts are not able to hold the clouds. And because the clouds are grown so strong, they contain so much of moisture, it leads to a strong, very strong event called cloudburst that has more than 10 centimeters of rainfall per hour or 100 millimeters of rainfall per hour in a localized area, 25 to 30 kilometers square. This can vary. You can see sometimes 30, 35, even 40, even 50. But you can take this as a reference. And 10 centimeters is something that is defined. It is defined by IMD. This 10 centimeter rainfall is the definition as per IMD. This is not something that is random. So you have to mention this. If you're writing an answer, this 10 centimeter criteria should come in your answer so that your answers become better. So these are about the cloudburst, where you mention about the 22 cloudbursts in 42 days or 12 cloudbursts in 2 days in Uttarakhand. Use these data so that your answer becomes better. And then use this flowchart if you want. How cloudburst can cause landslides. It can sometimes lead to land subsidence as well. Well, not that much, but sometimes it can, because the soil becomes weak. So it can lead to land subsidence as well. Am I clear? Is there any confusion? Any question? That is why I took all the three disasters together in order to make sure you are not confused between landslide and land subsidence. That is what I have witnessed many a times. You confused between the two. So that is all from my side today. I hope you have understood. If you have any confusion, if you have any question, kindly let me know in the comments. I will get back to you. I will address you in the comments. And if not, in the next class, I will get back with your answers. So that is all from my side as of now. See you in the next class. Till then, bye bye.